All right, so I think this is recording. Let's take a look here at number 2. We have a function f. It's passing through the point negative 12, comma 12. That's what f evaluated at x equals negative 12 equals 12 tells us. F and g are related through this equation. We want to transform this point that's on the graph of f to a point that we know that must be on the graph of g. For our transformations, we start with the domain. We transform the x-coordinates first. But everything is kind of in a bizarre way when you're having effects on the domain. Instead of doing multiplication first and then subtraction, we look at the subtraction first, and we do the opposite. Instead of subtracting 6, we add 6. Negative 12 plus 6 is a negative 6. And that's a shift of the graph of f 6 units to the right. And then we look to this 3, but instead of multiplying by 3, we multiply by the reciprocal, 1/3, and 1/3 of negative 6 is negative 2. That's a horizontal shrink by a factor of 1/3. Those are the only two transformations on the x-coordinate, so this negative 2 is going to stay negative 2 for the rest of the problem. We now move outside to affect the y-coordinates, the output of the function, and everything here behaves in a normal way. We do multiplication before addition and subtraction, and we do exactly what it says to do. So first with this negative sign, that's a reflection across the x-axis. That's going to change this positive 12 to a negative 12. And then if we multiply it by 2, that's a vertical stretch by a factor of 2. And then finally, we'll add 9, and I get negative 15. So I believe that the point negative 2 comma negative 15 is a point that must be on the graph of G. Let me know if you disagree, if I've made any type of silly arithmetic error, so I can correct the videos for other people, or if you're getting something else and have questions, and maybe you're confused about some things, because inside the parentheses some of this is confusing. I'll talk to you later. Bye.